6 years ago, an unexpected outbreak of disease spread rapidly through Queensland and New South Wales, devastating horses and businesses of the equine industry. This fast-travelling and highly contagious respiratory virus is known as equine influenza, or EI. It is capable of affecting all species of the equine family and is considered endemic to equine populations across most of the world. 2007 saw Australia's first outbreak of equine influenza starting in Sydney and travelling into Queensland, which can be seen in Figure 1A. Over 9,000 properties were infected, and Figure 1B shows the outbreak within the main cluster in Sydney. While EI can be shed via direct contact between horses and carried through humans, it can also travel over short distances, on large cough droplets, and over longer distances in aerosols of small droplet nuclei. The relationship between meteorological factors and the reasons behind the fast pace at which EI spread was unclear prior to the first outbreak. However, a team of researchers headed by Simon Firestone presented a research article titled "The Influence of Meteorology on the Spread of Influenza: Survival Analysis of an Equine Influenza Outbreak" in 2012. Meteorological variables were focused on to conclude which affects influenza A spreading during a hazard outbreak. Table 1 shows a number of explanatory variables associated with time to infection of properties in the largest cluster in Sydney. Air temperature, relative humidity, rainfall, and wind were the variables focused on for these results. By accessing contact tracing and laboratory results on horses investigated in 2007 from the State Government of New South Wales, variables could be collected and analysed. The government was notified of infected properties and the number of horses on each one. Different systems were used to estimate the association between potential risk factors and the times to infection of individual properties. 132 weather stations were accessed to collect data and hourly wind speed and direction and daily data for rainfall, air temperature and humidity. The Australian Bureau of Meteorology operated the weather stations during the 4-month study period. They were located within the cluster or within 20 kilometres of the cluster boundary. Figure 2B shows the hourly wind velocity data collected from 16 different weather stations. Kriging was used to interpolate the daily values at each individual property location for the time-varying predictors, maximum wind speed, rainfall, maximum and minimum surface air temperature, and relative humidity. These results can be seen in Figure 5. From the results collected for this research project, it was evident that the spread of influenza is influenced by specific weather conditions. The spread of EI increased on days that consisted of cool, dry conditions. The rate of infection was higher on days where the relative humidity was less than 60%, and lowest on days where the daily maximum temperature was between 20 and 25 degrees. Wind speeds of more than 30 kilometres an hour, originating from the direction of nearby infected premises, were also associated with an increased number of infected properties. Relative humidity, air temperature, and wind velocity have the most symbiotic relationship with an equine influenza outbreak and are the most influential on the spread of influenza. In conclusion, these variables have proved to be very insightful in regards to how EI could be contained if another outbreak were to occur in the future.